Welcome and thank you for joining me. In this lesson, we'll explore the graphs of reciprocal trig functions. Recall that the primary trig functions are y equals sine x, y equals cosine x, and y equals tan x. Their respective reciprocal functions are y equals cosecant x, that's a reciprocal of sine, y equals secant x, which is a reciprocal of cosine, and the reciprocal of tan, which is y equals cotan x. Now, in the lesson prior to this, we revisited the graphs of primary trig functions and their transformations. And if you have mastered this skill, then graphing the reciprocals will be very easy to understand. We'll start off with a graph of y equals cosecant x, which is the reciprocal of sine. What you see in here is two cycles of the sine function, one from negative 2 pi to 0, and one from 0 to 2 pi. The main features of the sine function are the domain of the function is any real number, and one cycle is 2 pi radians in length. The function has a maximum of 1 at x equals pi over 2, and a minimum of negative 1 at x equals 3 pi over 2. One cycle will have 3 x-intercepts at 0, pi, and 2 pi for this particular cycle. Now, remember that when we graphed these functions, we followed what we call the 5-point strategy. So we located the 5 important points as highlighted. So the x-intercepts, the minimum, and the maximum. And we're going to start off by using the x-intercepts, the minimum, and the maximum in order to build the graph of the reciprocal. Now remember that the reciprocal y equals cosecant of x is built based on reciprocating or dividing number 1 by sine of x. So at the points of intersection on the x-axis, y equals sine of x will have a value of 0, which means that the reciprocal then will have to be equal to 1 divided by 0. Now, this is not the first time that we have seen this division when we are graphing functions. If you remember when we graph rational functions, when the denominator became 0, we said that the function is undefined. And further to this, we said that when the function is undefined, because denominator is 0, vertical asymptotes show on the graph of the function. So what that means is that wherever you see x-intercepts of the sine, the cosecant will display vertical asymptotes. And I will do this for the negative side of the domain that I have selected here. So the vertical asymptotes in this case will be at negative 2 pi. So x equals negative 2 pi, x equals negative pi, x equals 0, x equals pi, and x equals 2 pi. Now, the next important point that we look into are the points that we look into are the min and the maximum points. Now, remember that at the maximum, the value of sine of x will be 1. So, therefore, the cosecant x will be equal to 1 over 1, which is 1. So what that means is that the points where the sine function reaches the maximum will also be points for the reciprocal. So we'll highlight them in blue as we build the graph of reciprocal. Now, next, we're going to look at the minimum values. So right here, we have x equals negative pi over 2, y is negative 1. So if the sine x has a value of negative 1, that means that the cosecant x, which is its reciprocal, will be 1 over negative 1, which is negative 1 again. What that means is that the points, or the minimums, on the graph of sine x will serve as points on the graph of the reciprocal cosecant x. So far, we have built the vertical asymptotes, and we know that the graph will have, or will pass through the indicated points. Now, next, we have to shape up the graph of the reciprocal. And for this, again, I'm going to try to explain another important concept in algebra. So, remember that cosecant x is built on reciprocals. So, what that means is that we are dividing number 1 by a number. And what I am going to bring here as an example is the division of 1 by a list of numbers that follow an increasing order. For example, if we have the numbers 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, and so on. So notice that here the denominator is increasing. As the denominator increases, the value of the entire fraction will decrease. So this would be 0.5, this is going to be 0.3, and this is 0.25, 0.2, and so on. So as you can see, the value of the fraction itself will decrease. So in other words, we're going to say that when number 1 is divided by an increasing value of the denominator, right, it will produce a decreasing number. So similarly, we're going to say that if we have a number 1, or a constant actually for that matter, it doesn't really matter if it is a 1 or any constant, if we are dividing it by a decreasing denominator, so for example, we have 1 over 5, 1 over 4, 1 over 3, 1 over 2, 1 over 1, then notice that as the denominator decreases, the value of the fraction itself will increase. So in other words, we're going to say that 1 divided by a decreasing denominator, or by a decreasing value, will give an increasing value. Now, translating this in terms of the reciprocals, we're going to say that wherever the function of sine x, the primary, is increasing, it means that the reciprocal will be decreasing. So we are going to visit each and every section of the graph together, and we'll see how this will shape the graph of the reciprocal function. So first, we're going to take a look at this section of the graph. Let me make this a little bit darker so we can see it better. So in this section here, we see that the sine of x is increasing. Recall that if you want to identify whether a function is increasing or decreasing, you always walk on the graph left to right, just like you read a book. And if your pen goes up, like it does in this case, it means that the function is increasing. So what that means to the reciprocal is that the reciprocal now will show a decreasing value. Now remember that the function of the reciprocal will have to follow the asymptote, that's the vertical asymptote in this interval, and it will have to pass through this point. So the only way that we can draw a graph that is decreasing, follows the asymptote, and passes through this point will be by going down this way. Now, another way you can think of it is this. If you look at this particular angle, you see that the value of y equals, remember this is 1, 2, 3, 4, 5, so that's 2/5. So the value of y for sine in here is 2 over 5. That means that the reciprocal will have a value of 5 over 2, which means that for this particular angle, we're going to have the value of cosecant x equal to 2.5. So it will be a point somewhere in here, up here. Okay, so next we are going to revisit the sine function, and we are looking into this interval. As you can see here, the sine function is decreasing, which tells us that the reciprocal should be 1 divided by a decreasing value. So 1 over a decreasing value will produce an increasing value, right? As we explained before. So we are going to draw the graph of the reciprocal. Right here, starting from the point where the function hits 1, and then we'll continue all the way up. And again, remember that if you want to prove that you are on the right spot in here, pick a point on the graph of sine of x, find the y value at that point, in this case again is 2 over 5, reciprocate it. Reciprocate it 2 over 5 will give a 5 over 2, or 2.5. So which means that at this particular angle, the value of the reciprocal would be 2.5. So the reciprocal will have a point somewhere in here, and obviously it's an increasing value, and then that's how we go up at this point. Now, if you understood this section of the graph, then the rest of it will follow the same rationale. So we are going to look into this section of the graph. This is a decreasing interval, which means that the graph of the reciprocal must be increasing. So imagine that in this domain, from negative pi to pi over 2, we'll have an increasing reciprocal that follows this particular asymptote and passes through this point. So the only way this graph would go is this way here. So we're going to draw this section of the graph. Okay, we can do a better job here. And remember that, again, we can follow the same strategy. If the y value at this point is negative 2 over 5, then at this very point, at this very x value, the reciprocal will be negative 5 over 2. So we are going to have to go all the way down to the negatives, negative 2.5 down here. Okay? Now, in the same way, we're going to shape the rest of the graph. As you can see here, we follow the same idea. So this is going to be an increasing interval for sine, which means reciprocal is decreasing. Increasing sine means decreasing reciprocal. Decreasing sine means increasing reciprocal. And one last section of the graph. So we have a decreasing sine, which means increasing reciprocal, and again, increasing sine, a decreasing reciprocal. So the graph that you see in blue, and this section obviously here that we kind of color-coded it for the purpose of kind of seeing and understanding it better, would represent the graph of the reciprocal of sine. Now, what are the main features of the function y equals cosecant x? First of all, this is a function because it does pass the vertical line test. And the points where the graph of sine had maximums turn into the local minimums of the function of the reciprocal of it. So the points where the sine of x had the minimum, so y equals negative 1, turn into the local maximums. Remember that there is no absolute maximum for the cosecant x. That's because the function will continue increasing to infinity, and there is no absolute minimum because the function will continue decreasing to negative infinity. Just like the sine function, notice that there is odd symmetry, which means a rotational symmetry. You see that the same graph will appear on both sides of x and y axis. So this is a reflection on both y and x axis, which gives the y equals cosecant x the odd symmetry nature. Now, this is the graph of y equals cosecant x. In the same way, we are going to build the graph of y equals secant x. And for this, please follow me in the next video. I hope that you learned and understood the process of drawing the graph, and not just remember the shape of it. Remember that it is always about understanding and not memorizing, not pure memorization. So I hope you enjoyed this. Thank you for watching. Bye for now.